Hey, everybody, and welcome to another episode of Ruby Rogues. This week on our panel, we have Nate Hopkins.
Hello, everybody.
Andrew Mason.
Hello.
I'm Charles Max Wood from devchat.tv. And this week, we have a special guest, and that's Kirill Shatrov. Kirill, do you want to say hi? Let us know who you are.
Hi, my name is Kirill. I'm a production engineer at Shopify, where I work on scalability in the platform, and I'm based in London, UK.
Nice. This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code DEVCHAT at Sentry.io to get 2 months free on Sentry's small plan. That's code DEVCHAT at Sentry.io. Now, Shopify doesn't have to deal with any scalability, right? I mean, they only run like half the shopping carts on the web and things like that, right?
Oh, yeah.
So I'm curious as we dive into this, you gave us a couple of articles. One was on the state of background jobs. The other one was on like capacity planning for web apps. I kind of want to start with this and dive mostly into when should I start caring about this, right? Because if I have a small app, it matters a lot less for a while. And then eventually I'll get enough users or enough people using the capacity to actually go, all right, now I really need to start thinking about this. So yeah, where do you find that the cutoff point is for this kind of thing?
Definitely. There is a lot of talk and technologies that it's natural for engineers to be super interested in, but the price of over engineering things and choosing some solutions that are maybe too complex at the stage where your project is right now, that price can be too high. And often the most resourceful thing you can do is just deploy it on Heroku and let it run. And it will cost a few $100s for your Heroku bill. For me, I think the cut point is around the time when you start losing the control of maybe your hosting costs, or you start noticing that whatever scalability problems you have start hurting your customers, and you start losing money either as a result of your customers being unhappy or as a result of the thing costing to run a lot more than a company can afford to run the business in a reliable way.
Yeah, that makes sense. It's interesting, too, that you've kind of tied it to those two practical breakpoints, right? A lot of people, they try and tie it to, well, I have a certain number of users, or I have a certain size of an app, or I have, a certain amount of server capacity, or, stuff like that. And it's interesting to me that a lot of this, you've tied it back to, oh, it's impacting the customers, or, oh, it's impacting my bottom line. And then it's like, oh, okay, how do I deal with this? I also think it's interesting that you mentioned that, it's easy to do if you just hand it off to Heroku and let them handle it. And I know that I haven't heard it as much from Nate, but I've definitely heard it from Eric over at CodeFund, that's kind of his approach. He doesn't want to deal with DevOps. He just wants to push it to the cloud and then, let them handle it. And he's willing to pay for Heroku to do it.
Yeah, that's our philosophy right now. But I mean, we're also short-staffed, right?
Yeah.
So we've got we're just 1.5 developers on the project. Other than we've got plenty of contributors that help us fix bugs and things like that. But there's only 2 of us that are full-time, looking at code, and Eric's really only about half-time looking at code, if that, right? So we don't have the time or the bandwidth to really delve deep into the ops story.
Mm-hmm. That makes a lot of sense. So I'm curious, Nate, at what point would you guys consider moving off of Heroku? I mean, would it be a cost thing or would it be something else?
We've found product market fit, and we are trying to scale it now. We're trying to scale on the sales side. Uh-huh. So as soon as we have enough customers and enough consistent revenue flowing in to allow us to kind of back off and look at our operations story, that's probably the time. So I would say we're probably maybe 6 months away from having the luxury of being able to look at that.
Yeah, that makes sense. So Kir, as somebody gets to that point, and I think it might be a relevant conversation then for Nate, but when they get to that point and they're thinking, okay, we're going to scale this, maybe they move it off of Heroku and onto a Kubernetes cluster, or they move it onto a virtual private server, something like DigitalOcean or something. What things should they be looking at then to scale their stuff up?
For any hosted services, like for instance, it's common to use hosted database as a service. I think it's important to look at whatever limitation that service provides, because any hosted service would have some kind of those. I remember I've read a blog post where an app had a very specific requirement for some Postgres extension that they've been using, and they switched, I think, three providers that gave them Postgres as a service, and they've been unhappy with each, and they obviously spent a lot of efforts. And finally, they got to run Postgres on their own, because having that very specific extension and requirement, that was a huge point for them. When choosing a provider like that, it's important to understand any limitations. And and from another angle, I think there is so many scalability related problems that you can run into, that usually you start looking at the one that's most critical right now. Like I've been part of projects where they run into scalability issues with the database layer with MySQL or with Postgres. And as they fixed it and iterated on it, and their database could accept a lot more load, they came to another bottleneck. And that bottleneck is different every time, depending on the business, depending on your patterns of the usage that's coming from your customers. So it's fixing one thing at a time, one by one. And sometimes that's a never-ending story, especially if the company grows large and there is a team works just on scalability, which is currently the case for my team at Shopify.
Yeah, that's a terrific point in terms of it really this is not a job that ever completes, right? It's something that you're always having to stay on top of it, especially if the company is enjoying any level of success. One cool thing about CodeFund is even though we're on Heroku, we're able to leverage some of the more advanced Postgres features like table partitioning and things like that, which has enabled us to continue to scale on that platform. We're hosted on 160 plus sites right now. And so we're seeing between 2.5 million and 3 million requests a day piped through the server. And now we are paying a premium for Heroku, but we're still, I think we're under 800 a month on our production setup, and we're probably a little over provisioned in anticipation of spikes and things like that. And so, we don't quite have the fine-tuned control that we would like to have. Your point on Postgres, as you want to customize that and install your own plugins and things like that into the database layer, that would be something that would be fantastic, because since we are using table partitioning, I know there's some plugins that just are not broadly available on the Heroku platform that would be kind of a luxury to use for us, that we've kind of had to work our way around some of those things. I'm curious about your experience and time with Shopify. How long have you been with the team, and what types of changes have happened since you've been with the company?
I've been at Shopify for almost 4 years, and I've always been part of the production engineering department, which deals with the infrastructure and is less exposed to the product. And just that department grew so much from maybe while I've been here, from maybe 30 people to now more than 100. And all of those people are working on the infrastructure and reliability, and with the motto of that our job is to keep the site up.
There's another aspect of scaling here, going from 40 to 100 people. Like how has the team scaled? Like what's the dynamic been like?
Yeah, it's interesting to follow dynamics in terms of team scaling in every organization, and I imagine it's a different story. It affected so many things. Like for instance, at the time when I joined, our Shopify is based in Canada, and most of infrastructure engineers were just one office. Now, people who work on the infrastructure are based in 3 offices, and there is also a lot of remote people like me. And then, as you grow, you end up investing into some of the things that you would never invest before, and have teams who work just on one part of development environment, for instance, or just on background jobs, infrastructure, something that I wouldn't have imagined 3 years ago.
So what is the technical portfolio for Shopify around, and like how has it changed since you joined? I mean, obviously
that's a great question.
There's been a lot of new tools and techniques and stuff that have come out, just over the last 4 years. And so I'm curious what the evolution of tooling has looked like at Shopify.
Yeah, that's a great point of discussion. So I think first, there is something I wanted to give the context to our listeners first, is that when Shopify was founded about 12 years ago by Toby Lutke, Toby was one of the first contributors to Rails, and he knew David, DHH, and they exchanged some emails. And around the time when he started Shopify on Rails was just a zip file that they exchanged over an email. It wasn't even some specific version published on a gem server, because I'm not even sure if there were any gem servers at that point. So from that day when he started on Rails, that app still exists. It was never rewritten. It's a monolith that has been around for more than a decade. We tend to put a lot of love into it to make sure that developer experience stays great, unlike it often happens that a monolith is just too slow and too hard to work with, that developers get so much friction and decide to go splitting or calling the monolith a legacy. It never happened for us.
I've got to interject and just ask a question on your monolith in terms of, like, I know Shopify is a very large company. How many developers have their hands in the monolithic code base?
My rough guess would be from 100 to 200 people, given that R&D in total is a lot more, because there would always be people working on other part of stack, also mobile developers, and so on, as you can imagine. So back to your point about how has the stack changed. In terms of tools that are familiar to listeners of our podcast, it's still pretty much a classical Rails app with all the things that come with it. In terms of the infrastructure, I think the biggest shift that I have observed of the company was move from physical data centers to the cloud, to Kubernetes. And that's another whole interesting story, because we were able to move to Kubernetes in cloud, one shop at the time. Given that we have millions of them, we wanted to make this process as continuous and fine control as possible. So we just took one shop, moved it to cloud, and progressed, and we were able to control that.
It's fascinating to me that you have upwards of 200 developers working on a monolithic Rails code base. Like, some conventional wisdom that I've heard in other circles and certainly bumped into in my career has been that if you're going to scale your organization, you apply Conway's law and break out into microservices. Like, and the conventional wisdom seems to be that that's really the only way to do it. And you guys are a terrific counterpoint to that. What are some techniques you've used to facilitate it?
I think one of the biggest has been adopting domain-driven development and splitting that monolith into, I would not call them namespaces, but it's kind of components. At least that's how we call them. There is nothing very secret or special about it. It's basically just a way to structure your app directory so that each team, each component gets their part. Therefore, it helps a lot to establish the ownership, because, for instance, as soon as you see an exception in production in some of the exception tracking services that you use, you see that exception is coming from components /support /app /model /something. You immediately know that's a support component, and you have all the metadata to find people who can help with that, and even an on-call escalation or a Slack channel where you can chat endpoint out. And we started leveraging that for to automate some of the things. Like, for instance, if the exception within one app happened in that component, we'll send a notification to their Slack channel, not to some generic Slack channel with tons of exceptions from all over the company. Establishing those ownership is, I would say, the main technique.
Okay, so a domain-driven design, and then you give a team like full stack responsibility, or at least all the areas of the stack that particular domain piece may touch, right? So that could slice all the way through front end, all the way down into the model layer.
Yeah, it's not as strict as you can imagine, and there would always be cases of reaching out directly from one active record model to another through components, through different domains. And that's not great. We try to build tools to discourage people from doing that, and for them to know what are the right patterns. Like for us, it's mostly entry points that are typed and declared and documented.
So this is kind of shifting gears a little bit. I'm really curious about the database infrastructure, because I know on Shopify, essentially you've sharded the database, or maybe not sharded, but there's multiple instances of the database, right? That backs this. How is that structured, and how do you manage that from an ops perspective?
Oh yeah, that's also a great discussion point. So also to give some of the context to the listeners, for all well-known Rails companies like Shopify, GitHub, Basecamp, name a few, that's been founded around 10 years ago. At that time, MySQL was the best known database that everyone knew how to run and operate. People were the most familiar. And some other, like Postgres, were not maybe as good or as established at that point. So that's one huge reason why this subset of companies, including us, are all based on MySQL. And I think it was around 2014, 2015, when we realized we can no longer fit everything into one DB. We figure out we have to find a way to scale horizontally. And for a multi-tenant SaaS application, there is a great way to do that. Since your tenants are always isolated, you don't have any joins between multiple tenants. So you can put tenants through different shards, through different partitions, and manage those independently, which also reduces the blast radius. If you have 100 shards, one is down for whatever reason, only 1% of your customers are getting some negative experience. And you go and fix that as soon as possible, but it's not all of the platform. So we invested a lot into sharding. In terms of application logic, it's mostly done on Rails layer. We have a Rails team at Shopify that helps to steer that into the best direction possible, at least from the Rails point of view. And from the ops point of view, it's just a lot of shards that can be located even in different regions, and which also can allow to isolate some tenants geographically.
So let me just recap to see if I've got the picture in my mind correct. So we've got a Rails monolith that's kind of structured with kind of these domain areas of responsibility. That's how you structure your teams. And the way you've scaled this, at least up to this point in the conversation, is you're just dealing with just mountains and mountains of data. So you've sharded your multi-tenancy across different database nodes. But for the developer, it can just look like a typical Rails application.
Correct. And something to add is that our goal is to make all that sharding complexity hidden away from developers who write product features. For them, it may feel like there is just a database with a lot of tables that represent the business model. But underneath, there would be some smart shard selection that would happen at the beginning of the request, for instance, that would select the right database. And I mentioned this just for MySQL, for relational database, but we've realized that it makes no sense to have sharded MySQL, but just one global Redis, because regardless of how well you shard, that one global Redis or that one global memcache would still be a single point of failure. And as you can imagine, we learned that lesson by experiencing those single point of failures. So our philosophy is that every resource would be sharded. So there would be a smaller instance of Shopify that has its own MySQL, that has its own Redis, that has its own memcache, that helps with this isolation.
So with each web server, essentially, or maybe partition of web servers that scale horizontally, all of those would not necessarily have a local copy of Memcache and Redis, but maybe just a shared one for that cluster of web servers?
One thing I should note is that stuff like web servers, it's still all shared capacity. And it's only resources that are isolated. So any web server can talk to any partition or any like smaller instance of Shopify. It's mostly the matter of selecting the right path depending on what's the customer.
So now I'm a little curious in terms of, because there's obviously a pretty significant coordination piece there. When the request initially comes in, and then you assign the correct Memcache server, the correct Redis server, and the correct MySQL server. How much of that infrastructure did you guys have to build at Shopify, and how much are you leaning on the database providers for those things?
Honestly, I think it's mostly all in-house built. And to give a bit of context about that, it's mainly a component called Sorting Hat. I like the name. That is using some
it sounds
global
magical.
route. The Sorting Hat is using a global lookup table to find which domain, which shop is on which partition. It gets the partition, and then it goes to the location of that partition, can be US West, US Central, US East, somewhere else. And then it just hits the right database located in that region, and the right through Rails, and mostly through HTTP headers. And what I find very interesting is that we were able to build all of that on top of Nginx, since Nginx allows you to write scriptable Lua modules where you can implement any kind of logic. In those Lua modules in Nginx, you can query your database to look up something where that tenant lives, and then you just proxy that through Nginx and you manipulate the headers and just make this work. So it's quite a lot of infrastructure that we had to write. But at the same time, as I talk to colleagues at different companies, it's all custom tailored, and there is rarely a same stack, same use case. So that would be a bit hard, maybe a bit hard to share and abstract. So yeah.
How much of that infrastructure tooling is open source? Is that all secret sauce internal stuff, or have you open sourced some of it?
We try to open source quite a few things. There is also a lot of conference talks that will link to show notes that give a way better overview of the architecture than I just explained. The routing layer itself, I wouldn't say it's open sourced, but there is lots of information out there for someone who would want to build and use same techniques.
So that's probably a good segue into additional scaling aspects. So you've addressed a lot of the persistence layer, or pretty much the entire persistence layer, horizontal scalability, but you still have response times to deal with, right? And so one way to make response times fast is through background jobs. And I know you've got quite a bit of expertise there. What is the approach and architecture of Shopify's background job system?
Well, and just to pile on here real quick, it seems like when people start talking about scaling Ruby or Rails apps or Sinatra apps or whatever, this is one of the first things people reach for, right? Because any long-running task, they just shunt it off to background job. and, report errors back to the user if they have to. And it shortens the response time because then it's, hey, go do this job instead of I'm going to grind through the work of doing this job.
Yeah. And before you jump in with an answer too, I mean, one thing to bear in mind is like some of this stuff is it's baked into Rails with active job. But I mean, you don't even have to set up Redis or anything like that to support it, right? It'll run it on a background thread out of the box. So what is the path for a developer? Like kind of Chuck's lead-in question. You start on a small project that's maybe a little hobby thing, then it starts to get some traction, and then maybe it turns into a business. What does the evolution of kind of evolving that background job handling look like over time?
Oh, yeah. And to note that, like myself, for some of the bad projects, I run background jobs exactly in the background thread in those Puma processes. Yeah, just because it makes no sense to pay for extra, for instance, Sidekick dynos on Heroku for those bad projects. And exactly as you pointed out, it makes sense to start with something as brutal as a background thread. And then I'm really happy that Ruby community has a project like Sidekick and Mike Perham, who is behind that project, who has pushed the community to adopt some best practices around background jobs and also offers 99% of what community needs as an open source project. And for the remaining of 1%, when you get to that point, you can buy a pro or an enterprise edition. And I'm pretty sure that when anyone is at that point, that's actually quite an affordable software to buy as a company. And just like most of the community who is using Redis, Sidekick, Shopify is very similar in terms of setup because we've been around for such a long time. We've started with Rescue, if anyone remembers. That was a pre-Sidekick era library to basically achieve the same. So we still run Rescue, we run Redis. We got to rewrite most of Rescue internals because we're multi-tenant and we want to share some of the capacity and reuse that between tenants, which we can dive into if you say later. I guess the first question from you and from some of the listeners could be why we're not on Sidekick. And the answer, I would say, is mostly the legacy part and also how much we know the stack and how much we customize it for us at this point. But we're also starting some smaller apps at the company, some smaller Rails apps. In fact, in addition to the monolith, we probably have a couple hundred other smaller Rails services for something very specific, or maybe something just employee facing. And all of that would use the recommended set of libraries that includes Sidekick.
Yeah, that makes sense. Hey, folks, I want to tell you about a great system that I just found that has made my life a ton easier. That's Cloud 66. A lot of folks think that deploying is a pain. I kind of grew up as an ops guy, and so I never really felt that way until I tried Cloud 66 and realized that the way that I was doing it with Capistrano, pushing stuff up to DigitalOcean, it really was kind of a pain. And when things didn't work, I had to go in and I had to bang my head against the wall to figure it out. Plus, all the setup stuff was just a big headache. And what I found with Cloud 66 is that it's a really nice way just to get everything set up. I just told it I had a Rails app, and off it went. It set it all up, it does the deployment, and now that I have other developers working with me on Podwrench, which is what I'm using it for here, all I have to do is give them access, and then they can go push the button for me, and it gets deployed. It's really nice. It's straightforward. It has all of my environment variables in it, so I didn't have to do any setup that way either. I just had to go in, put in my AWS credentials and a few other things that I was using for third-party apps, and it set it up and ran it. So if you're looking for a great solution for deployments, use the promo code RubyRogues, that's all one word, capital R, Ruby Rogues, for $66 off Cloud 66. This only works for new users, but man, it is awesome. So go check them out, cloud66.com. I'm also working on a software as a service. I'm sponsoring one of the bigger conferences that serves that niche, podcasting, in August. And so I anticipate that things are going to grow. And yeah, I have a lot of things that I am pushing into the background jobs right now just because, I want to get the response times down. But one thing that I'm wondering about, and I'm kind of tempted to go with Heroku, but part of me, I don't know. I have this mental block about paying for something that I could probably figure out the scaling on myself, or at least do some, a couple of minor things to help with the performance and scaling that way. So what should I be looking at next? It seems like you all have kind of gone toward the cloud, and I'm wondering if that's the right answer, or, beyond background jobs, what's the next step?
A step to reduce response time?
No, it's more a step to just get it to scale, get that, be able to handle more traffic without having the site slow down.
Right. There would always be some kind of bottleneck, which is depending on if you have a good setup of tools, should be possible to find. And for us, that bottleneck has changed through the time. And I would guess there is no single answer, because maybe there is something in a web server in a controller still spending quite a lot of time, which slows down the response time. Or maybe it's all database that's the bottleneck. Or maybe it's Redis. Or maybe the Rails reaches out to some external service that is not located too close to it, which increases the latency and also impacts response time.
Yeah, that makes sense.
I'm curious, what criteria do you use to determine what should move into a background job? Obviously, you may hit some latency on a particular request and see something that is kind of low-hanging fruit to move to a background job. But just because you moved it to a background job doesn't mean you've actually addressed the root of the problem. You've just moved it out of the request flow, right?
Oh, yeah. And a very common pattern that I see in people do with jobs is, for instance, you want to iterate over all users in your app and do something about each of them. Maybe remind them that they need to add a credit card, or maybe if something expired, or you want to send them an engagement email. When you start, you have just 100 users, so that job works off pretty quickly, under a minute maybe, depending on what kind of work that is. When you grow to thousands, hundreds of thousands, to millions, and a job to iterate over 1 million users and to check balance of each of them, that job starts taking days or weeks. And how do you solve that? And it's just so easy to introduce that problem. You just do user.find each in a job, and it works, but until the point when it stops. So the way how we solved it, and that's actually all open source, we'll also link in a show note. We've solved that by making every job interruptible and preserving a cursor, so that a job would progress for a bit and then maybe it would get restarted for some reason. But basically, this allows us to iterate over really long collections and do some work with them and never lose the work that has been done.
Nice.
Yeah, that's really cool. I'm going to check out the Shopify job iteration. That sounds really, really interesting. One of the things that we've done at CodeFund is when we're iterating across, of course, we'll do like a find in batches, and then we will just enqueue the smaller work. So when the large job fails, it's essentially idempotent and can be just rerun again without impacting things that may have been half processed or halfway chunked through.
Yeah, that's the approach that I take as well.
An interesting side effect of that could be that, again, if this leads to a fan out of 1 million jobs, because if you have 10 million users and each batch is size of 10, for instance, like the numbers don't really matter. But the point is that if the fan out of so many jobs, we need to remember that something like Redis is always limited in memory. And there's been so many times across every organization where I worked, that people would push Redis into out of memory state. And unfortunately, there is no, I would love to have a great solution for that. But every time we want to do something like you described, iterate in batches, enqueue something, we have to be mindful about what's behind that. And most
Absolutely.
commonly,
Yeah, I've been bit by that as well. You start dropping jobs because there's no memory left. Certainly happens at times when jobs might be failing, right? Sidekick gives you some pretty nice fail-safe capability where it will reattempt those jobs. But if you've got a bug and not a lot of memory dedicated to your Redis instance, then of course you may start losing work that may be critical to the business.
Yeah, I could see that. I haven't run into that myself, but I could definitely see that happening.
This is a great reminder about all sorts of databases that exist there, and maybe push someone to learn about that. Because at the end, Redis is in-memory database, which is bound by some RAM that you give it. Can be gigabyte, can be 4, can be 16. And that backlog of jobs would not be backed by something that can be written on storage that's bigger than RAM, which would be disk if it's, for instance, MySQL Postgres. So something that we would really like to find is a store that could persist those things on disk with a performance not too far and features not too far from Redis.
Redis does have the capability to write to disk, right? To flush itself out to disk.
So that only helps to have a snapshot in case the computer where Redis is running reboots, but it still doesn't allow you to store more than the RAM that you have.
Yeah, I mean, that's probably a great argument to move to cloud, right? Because on Heroku, it's just a one-button click when you see the memory filling up to scale out or scale up your Redis storage capacity.
Yeah, and a lot of cloud databases or cloud instances, they have methods for compensating for that, and so they will just migrate you to a bigger instance, or basically allocate it new memory without you even having to click it.
As far as that workflow is validated and people are certain that it will work, that's a great feature of cloud providers.
One of the thoughts that I've had architecturally, which would be kind of neat on the background processing, would be some jobs obviously are a bit more ephemeral and less critical, and they could be handled in a little bit more localized fashion. So it'd be neat to build a routing layer that was intelligent, where you maybe had three stages of Redis or just background job storage, right? One could be, this is very ephemeral and not very important, so we'll just let it be handled in process on a separate thread. So we'll route that job over there. Or it may be that this web server, the job's still kind of ephemeral, but a little bit more important. So we could have a dedicated Redis instance sitting on the web server that has just a small set of dedicated memory for that. And you could push those jobs there to handle some of that back pressure. And then for the really important stuff, you could heft those off to like your appliance tier of Redis storage that gives you the full capacity across the entire application.
Oh yeah, we haven't done something like this for jobs, though I think it could help a lot. But in general, like in terms of building systems, I think this is a common case of defining priority for different workloads, which also allows you to shed some of the load. So for instance, you would have, it doesn't have to be jobs. It could be something as basic as web requests. And there are requests that go to something that's very important to the business, maybe checkouts, which has the highest priority. Then you have something medium priority that's maybe browsing just the admin. And then you have something low priority, like checking out robots.txt or checking out sitemap or hitting an API. And by declaring priorities to those requests, when you're at the load, you can shed some of those that you don't need. And this idea comes mostly from the largest companies in the industry. Like Google has lots of papers and books how they do it. And as you can imagine, every request to Google service would have some kind of priority. And they actually shared those. Like I'm pretty sure that mail is higher priority than watching videos on YouTube.
It's really interesting. And one of the neat things about Sidekick is it provides, like, if you couch that in terms of background jobs, Sidekick provides some of that facility just out of the box, even for a simple deploy, right? Because you can prioritize. You can say this is in the critical queue, this is in the default queue, this is in the low priority queue, and Sidekick will drain the higher priority queues first. Now you could start there and then eventually expand out and say, well, I'm going to give a set of dedicated worker virtual machines or dynos or whatever to process a particular queue, and I may even give a separate dedicated Redis instance or tier, for that particular queue. But you can start with just a simple Redis instance and the default Sidekick configuration. I'm going to say, just for anyone listening, because when we're talking about like scaling large systems, right, like Shopify. But if you're starting a Rails app, for me, the go-to is pretty much, I always reach for Redis, Postgres, and Sidekick, along with everything else that comes out of the box with Rails. That's pretty much what I always go for when I start a new project.
Yeah, I mean, I've used Rescue in the past for a lot of projects, and then I've moved into Sidekick for my newer stuff. But yeah,
when is it too much to background something, right? So I wrote a gem that allows me to essentially background any method that hangs off of an active record model, which is really convenient. But what I found is it makes it almost too convenient, where if something seems to be slowing down a request, you can just do a .defer to the method name and it would stick it into the background, which is great, but it got abused and we ended up with far too much running in the background, hitting those problems you're talking about, like exhausting memory and stuff. So how do you determine what should be backgrounded?
That's a good question. And frankly, as someone who's spent quite a lot of time on that part of stack, I'm not sure if there is a single answer. And I think it's somewhat related to how, for instance, if it's active record and SQL queries, how heavy are those queries? If your request timeout is 30 seconds and just one SQL query that's for some reason heavy, some kind of aggregation takes 10, and you need maybe to run a few of those, there is no way to fit that into a web request. And of course, it might not make a lot of sense to do the premature optimization, and it can be fine to just start with everything in a web request in a controller, and then you find out that's the thing where your app spends most of the time in web request, and you just move that to a job. Because for simple apps, that's maybe it will never be a job, and it will scale fine for the next few years.
Yeah, I wonder if a good approach would be to first, this probably very much depends on if you've got paying customers that are being impacted, right? So if paying customers are being impacted and you've got just some inefficiency in a query or some aspect of a web request, maybe you background that, but you also you put it in some type of planning process where you revisit that job and try to actually optimize the real root of the problem.
Yeah, I tend to use the background jobs when I have a performance issue in the request pipeline, like we've talked about before. And then if there's a problem with running it in a background job, it's timing out or, something's breaking or something like that, then I revisit it from there. I don't know if there's a silver bullet. I think a lot of times it's context specific and you just have to, okay, I'm moving this out of the request pipeline. Okay, now it's having a problem here. So now I've got to address the issue there. And eventually it kind of bubbles itself up to the top of your tech debt queue and you address it. So one thing before we wrap up, do you have like some favorite tips or tricks or approaches that you do at Shopify or have done at other employers that make this easier, or something that you just feel like is something that you did that you're proud of?
Yes, for someone who is curious about performance and fixing those kind of bottlenecks, my best advice would be to study all the set and variety of tools that you can use. These tools can be as high level and web-based and simple as New Relic and some of the similar services that you can connect to your app and see insights, to more system level tools like, for instance, strace. The amount of times where strace saved me and some of my colleagues at the middle of of the service disruption. It's so hard to count those. And my advice is not necessarily about S-trace, but knowing the wide variety of tools that you can use. Some of those tools are very Linux specific and system level. Some of them are Ruby level, like RBSpy, a great tool by Julia Evans, or RBTrace. And then there are some services that offer those kind of things. So if you know that range of tools and you know which one is the best for something that you're looking for, you pick it up and fix the thing.
Which I know we go to wrap up soon, but I've got a couple of questions to put you on the spot here. One is, do you know what the request volume that Shopify does per second?
The public number that I can say is about 80,000 requests per minute.
And what about background jobs? How many background jobs are being processed per minute?
That's a great question. And to be honest, I don't remember those numbers just out of my head. Yeah.
I guess it probably suffice to say that it's a lot, right?
Yeah, it's a lot, and it can be very spiky. And there is a huge difference from steady state and spiky state, because Shopify is also hosting some of the world's largest sales, sometimes for celebrities, sometimes it's worldwide cups and some special sales that where millions of people try to crash Shopify stores.
Yeah, I can imagine. CodeFund is tiny in comparison. And since January, we've done over 300 million.
Wow. That still feels like a lot to me.
Yeah, we keep changing what's in the background, what's not in the background, so that we've had that number kind of artificially inflated at times. But still, yeah, that's a lot of background work.
Yeah, makes sense. As a Ruby developer, you've probably used Redis for queuing and caching. But if you're like me, you've never completely understood it. You just followed the tutorial to set it up and then hoped it'd stay up. Now that I'm building my own services for other people, I realize that you and I often don't have the desire or time to run an ops or DevOps team, or do it yourself. Plus, since you're not a Redis expert, you're not exactly sure how to know what it's doing. That's why I love RedisGreen. No setup. It runs on any AWS region I want, so I can run it near me. And the tooling is amazing. I have to tell you about this feature, actually. It actually maps the memory you're using and tells you where all the memory is allocated. So this makes it really easy to see what's going on in your Redis setup. It also runs on AWS, so it scales easily and can alert you when it hits certain thresholds in performance or capacity. Sorry for going all fanboy on you, but I love this tool. Here's the thing. If you don't want to do ops or are already on Heroku or something, then use RedisGreen for the rest. It's simple, yet powerful. Check them out at redisgreen.net. All right, well, I'm going to push us to picks. Nate, do you want to start us off with the picks?
Sure. So I guess one pick for me today is open source, how fantastic open source is. I've got a thing on the side that I'm doing for my brother-in-law, and it's basically a CRM. So I went kind of diving around GitHub for open source tools that I might be able to use to set up for him. And I found Fat-Free CRM, which is a Rails-based CRM. It's a bit antiquated on the the way it looks in terms of the UI and UX, but it's pretty fantastic. The data model's solid and it meets all of his needs, which is terrific. The other pick I've got is cats. So we've got a Maine Coon and a Russian Blue, and they just provide so much joy for my girls and for the family in general. So highly recommend getting a pet, and especially a cat.
Nice. I'm going to step in here with a couple of picks. The first one that I have is a challenge that I've been doing. This is a challenge that has been less fun with a broken arm, but I started it because I really want to prove to myself that I can do this. And doing it with a broken arm, I wasn't going to wait to heal because it's several weeks to heal a broken arm. Anyway, the challenge is called 75 Hard. It comes off of the MFCEO Project podcast with Andy Frisella. And I picked that on the show before, his podcast. But anyway, it's basically a challenge that he made up. But it essentially is a challenge to prove that you can, do what you've got to do for 75 days. So there are 5 rules, and if you violate any of the rules, then you have to start over the 75 days. And the first rule is you have to work out twice a day for at least 45 minutes each time, and one of the workouts has to be outside. So if it's raining, if it's cold, if it's hot, if there's a hurricane, whatever, you're going to work out outside. And basically, he says that's just you push you through sometimes you have to do stuff when the conditions aren't ideal. The other rule, you have to drink a gallon of water every day. You have to read 10 pages of a book every day. You have to choose a diet and stick to it. No cheating every day for 75 days. So a lot of diets, people are like, well, I take a cheat day every week. No cheat days. No cheat days on 75 hard. And then the last one is you have to post a status photo to social media. And so, yeah, I've restarted twice so far. The first time I forgot to read the 10 pages, which was dumb. It was the one thing I kind of took for granted that I do, and I didn't do it. The other one, I got a salad from Costa Vida, and I didn't realize that I hadn't told them to take the rice out of it, and I've been doing the keto diet. So, yeah, so I started over. I felt really dumb about that. I was like, I know they put rice in it. I don't know why I didn't ask them to take it out. So, yeah, so it's just kind of learning to adapt to some of this stuff. But I'm definitely enjoying the process. And incidentally, just to throw it out there, so I've been doing the challenge for about a week and a half, and and I'm currently on day 2. Just to throw that in, right? Because I had to restart. The flip side is that I've lost 10 pounds in a week and a half.
Awesome. That's a serious program. Like, you're going to be committed.
Yeah. But he says it's a mental toughness challenge, right? You're going to go, and some days you're just going to have to push through, do some stuff that you really don't feel like doing. Yeah, like the run that I have scheduled today, it'll probably be both of my 45-minute workouts together, because it's one of my longer training runs for the marathon I'm going to run in October. And yeah, I'm really feeling it today, especially with my arm and everything else. I do not want to go out there and do it, but I've got to suck it up and go do it. So anyway, but yeah, I've got to go do 2 workouts tomorrow, and tomorrow's a holiday. So yeah. Anyway, so that's my pick. If you want to go follow me on Instagram, I think my handle is Charles Max Wood. Then I've been posting my my social media posts there. I tend to try and post them to Twitter and Facebook as well, but I'm not always great about that. I'm pretty consistent on Instagram. So anyway, Kira, do you have some picks for us?
To be honest, I don't know the format very well. If you can just do the LDR.
Are there 1 or 2 things that you think everybody in the world should know about? We'll put it that way.
Right. This one, I think it would be interesting for the main audience, like Ruby developers. A couple of weeks ago, I followed a hacking guide from MRI committers that shows you how to build Ruby, how to change some simple source in C, how to rebuild it again, and see how it works, which also allows you to try all the new features that are coming with Ruby 2.7 because you build it from the master branch. So you can go and try stuff like pattern matching. That's something that you're excited about. And the reason why it can be interesting for any Ruby developer to try is because you get to see all the magic behind it, just all the C code, and it becomes no longer just a thing that some Ruby committers that I have no idea about build, and it becomes something that you can understand a little bit better maybe. And I think that hacking guide was also made to reduce the barrier to start doing that open source. So I think this point falls back to the big that Nate brought up about open source being awesome. We'll link that too.
Very cool.
Yep. Cool. One more question. If people want to find you online, see what you're working on these days, how do they find you?
Yeah, it's Kirill Shatrov on Twitter or Kirs on GitHub.
Awesome. All right. Well, thank you for coming. This was really interesting. I want to ask like a dozen more questions, but we just don't have time. So maybe we'll have you come back.
Thanks for inviting. We'll be happy to come back.
All right. Well, let's go ahead and wrap this one up, folks, and we'll come back next week with another episode.
Thanks a lot. Bye.
Bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.